This is our group app, Bournemouth Visits, by Lizzie Beadle.
Oscar Cook,
Charlie Borman,
and Archie Washington.
The key feature of our app is using Firebase as the main component. The users of this app will be people who like to travel. The reason for this is because the app game allows the user to walk around Bournemouth and visit well-known destinations throughout learning more about the area. This walk works through the user seeing locations and pins dotted around the map. Once you get close to the significant locations, you can then interact with the annotation. This is constructed for a map kit and location tracker, which are linked together in the main view controller.
For version control, we used GitHub as we needed to collaborate as a team. This was done by linking GitHub to the Spirit Tree, then adding all the rest of our teammates as collaborators. To open file, we cloned the file onto the Mac. Once made changes, we then committed changes to the master program, then pushed origins to confirm changes.
For the components of Xcode, we had to understand the environment. For instance, the toolbar at the top allowed us to access the simulator to see the app run. The navigation area on the left gives access to view controllers and storyboards and other files. The editor area is where the codes take place and where you can edit. The debug area is useful in fixing any unwanted errors by providing a print when simulating the app. The utilities area gives ability to edit graphics like buttons and labels and name identifiers.
A very significant class is our main view controller. This is where the majority of the app functions. It has our location manager delegate, map view delegate, and second view controller delegate. As well as this, the code within the class loads locations from Firebase, as seen here. The naming conventions that we use is mainly camel casing for our classes, variables and functions. We did this as it reduces the chance of errors. We made names sensible so all our teammates can understand it. For instance, we named classes view controller and custom annotation. We also made sure that the image titles are the exact same as the annotation titles in the assets. So the correct one would appear depending on which annotation the user interacts with.
In our app, we use documentation. From when there were errors, we would comment out the codes when submitting it to the desktop master, or from when we comment out notes to say what to the other group, like what each code meant.
The main graphics in our app include when we click on the annotation, it comes with an image of location from the assets folder. This image was made sure that it was 3000 pixels for a small icon or a small space because we wanted to make sure that we did not create bloat within the image.
A delegate's purpose is to make sure information is passed through classes, which mean delegation ensures classes and methods work together. We use location manager. Location manager delegate to self, which tells the delegate that the new location data is available. This tells the delegate that the location manager was unable to retrieve a location value, and tells delegate that updates will no longer be deferred.
Instead of regions, we made the choice to measure the user's distance from the annotations. This is because you are limited to 100 regions per project. If we were to expand this tourist app past Bournemouth, then you need lots of regions. Because of this, we thought it would be more efficient to measure the distance. As you can see here, we've chosen 200 for this test. To help test and ensure that this app will be successful for actual users, we simulated distances and user tracking between our clues created on the UI map. This allowed us to understand if the location tracking is successful and also see if the regions placed on the map work well enough to be clicked when the user is in a certain distance away from it.
Our life cycle starts showing the map view of the user general location. It automatically zooms into the relevant area. From this stage, the screen tracks the user location around the area as they move throughout the designated area of the game. When the user gets near a destination, they have the chance to click on a destination, which will segue to a new screen showing information around the area.
The CocoaPod we use is called Firebase. We chose to use the Firebase database in our app to draw the coordinates from our annotations and the location descriptions. If we were to locally code this instead of store the data in Firebase, every time we wanted to add new locations or update the information, we'd have to submit a new version of that application to Apple. So the benefits of using CocoaPods in regards to our app is that we could constantly update and add the locations whenever we please.
So this is our Firebase. We have the locations here. Each one has its unique identifier string. On each one we have the name of the location, which is the annotation title. We then have the coordinate of it, so it shows up on the map, and then the description, so that will show up on the second view controller. And we have this for each one of our locations.
Each time we committed an update to the app, we named and labeled it correctly and re-uploaded the app to the shared workspace on GitHub desktop so that we could go back and forth between our changes and also to allow our group to access the app.